All right, come on in, guys. We'll just wait a minute for a few more people to arrive here. Just wait a bit. I'll get my PowerPoint going here for you. All right, well, I have a fairly small number so far. Just checking on the chat here. Can you guys hear me? Okay, awesome. All right. Okay, well, I hope everyone had a wonderful weekend. So here we are, starting another week of meds. One big announcement to make. Not everyone has handed in the blood typing and blood tests worksheet. And I really need you guys to do that before you write the quiz, and I'd like to get it back to you. So here's the announcement, and I'll put this on a Google Classroom when we're done our class today, is that I'm going to postpone your blood vessel and blood quiz until noon tomorrow. So it'll start at noon tomorrow and it'll go until noon on Thursday. All right. Any questions about that? So if you have yet to hand the blood typing and blood test worksheet into me, if you can get that into me as soon as possible so I can mark it and get it back to you. Okay. All right. So the quiz is postponed. We're going to finish the circulation notes today. I'm not going to give you a worksheet on it yet. Because I want you guys to study. I want you to study for your blood, so study your blood vessels notes. I've handed back the worksheet for blood vessels so you can study that, and then study your blood notes as well. So you have that, so you can do really, really well on that quiz tomorrow, okay? So there won't be any worksheet today for the circulation, but I'll post something on Wednesday, and on Wednesday I'll also get you guys started on a little project. Alrighty, so that being said, let's talk about circulation. Any questions, anything, any concerns that you guys have, anything you want to post on the chat or just talk? You can unmute your mic. I don't know about you guys, but I'm super happy to see the snow starting to melt. So it's making me feel like maybe at least even though we're in a pandemic, the sun's shining and it's getting a little nicer outside. So that makes everything a little more tolerable. Okay, so I'm going to share the circulations, and let me just find that here. There we are. All right. And let's just go to where we were before. Okay, actually, I'm going to just keep it where it is right now. We're just going to review a couple of the highlights from last time when we talked about it because we haven't done any worksheets on this yet. So I just want to slideshow. Why is this not wanting to do what I want it to? There we go. All right. So first of all, just looking at the chat, can you guys see the PowerPoint? Quickly review this. So if we take a look at the PowerPoint, so this is what we did last class. So I'm just going to quickly run through what we did. And we talked about how capillaries are the only blood vessels where material exchange can occur. And that can happen because it's leaky, okay? And then we talked about what happens specifically at the lungs and what happens specifically at the body tissue. So we want to make sure we know the difference, right? So we talk about lungs, we know that oxygen's going from the lungs into the capillaries and carbon dioxide is going from the capillaries into the lungs. Okay. We talk about the body cells, oxygen's going from the capillary to the body cell, and carbon dioxide is going from the body cell to the capillaries. Okay, so we want to make sure that we're understanding what's going on with that. All right. So there's three major control factors for how materials move in and out of capillaries. So the first one we talked about was diffusion. So things move from an area of high concentration to an area of low concentration. Okay. We talked about what an alveoli is and how there's a capillary network around it. Okay, so you want to make sure you're reviewing this. We talked about diffusion. So carbon dioxide from body cells diffuses, right? And then we talked about what can't get through. So this is really important. So you want to make sure that you're understanding what can't get through. We mentioned this last class, right? So plasma proteins and blood cells usually don't make their way through a capillary wall unless there's an exception, unless something's happened. Okay, so make sure you know that. So that might be something I ask you later, right? So make sure you're understanding that. All right, so let's move on to the next slide here. So again, we're just reviewing what we did last class. So we also need to understand the concepts of blood pressure and osmotic pressure, right? So blood pressure is higher on the arterial end and lower on the venous end of the capillaries. So remember, the arterial end, that's the end of the capillaries that's connected to the arteries, and the venous end is the end that's connected to the veins, right? So we want to make sure that you're understanding how that works. So when we balance blood pressure and osmotic pressure, we get net pressure, okay? And the pressure on the arterial end, and we're just going to look at this picture because it summarizes it. So we talked about this again last class, but the pressure on the arterial end, whoops, sorry guys. There we are. The pressure on the arterial end of the capillary is higher pressure because that's the stuff that's closest to the pumping action of the heart. And the venous end of the capillary is further from the pumping action, so there's less pressure, okay? Osmotic pressure is fluid moving into the capillary to balance out what's going on with the proteins. So there's a high concentration of proteins, okay, plasma proteins inside the capillary, and there's a low concentration. So there's not very much out here, but there's lots of plasma proteins in here. So that means the water is going to move, or the liquid's going to move inside. That's the osmotic pressure to balance that out, to dilute it, okay? So because we have the same amount of plasma proteins on the arterial end that we do on the venous end, that osmotic pressure stays the same. But osmotic pressure is due to the proteins that are in the plasma. Okay, so you want to make sure you're remembering that as well. All right. Okay, we just talked about the pressure. Okay, peripheral resistance is another concept we talked about last class. So that's what's resisting the movement of blood against the blood vessel, okay? And there was 4 factors we talked about that were associated with peripheral resistance, okay? So one is vasoconstriction. So when the blood vessels constrict, what that means is there's going to be more pressure because more blood is moving through a smaller space, okay? And we want to understand why that happens, right? So we don't have conscious control over it. Our body has an involuntary response for that to happen. When elasticity reduces, so our body can't handle the opening, or when the heart beats and we have this big volume of blood, so big volume and then little volume, big volume, little volume, and we need that elasticity to be able to handle that. When our blood vessel gets less elastic, then we can't handle that as well, okay? Increased viscosity. So that can happen when we're dehydrated, where we have less water in our blood, so way too many blood cells, or less water, right? So it's thicker, or we have way too many red blood cells, so polycythemia. And then reduced blood volume can make it so there's less resistance, right? And that happens when we hemorrhage. So when we're bleeding out, we're going to get less resistance, okay? All right, so we want to make sure that we're understanding that when we talk about blood pressure depends on two things. It depends on cardiac output, and we reviewed that last class, and peripheral resistance. Okay, so these are the factors that control peripheral resistance: blood vessel diameter, vessel elasticity, blood viscosity, and how much volume we have in our blood. And these are the factors that control cardiac output. Okay, all right, so that's just a real fast review of what we did last class. And then we talked a little bit about what does it mean really to have blood pressure. So we want to remember that's how much pressure is pushing on the inside walls of the blood vessels, right? And then we can see the further away we are from the heart, the less pressure. So the most pressure is in the aorta. Oops. There we go. The most pressure is in the aorta, right? Because that's coming from the chamber of the heart that has the most muscle, which is the left ventricle. And then the least pressure is the vena cavae, so the inferior and superior vena cava, because they're the furthest away from the heart. Okay. And then if we look at the next diagram, right, this tells us where we see areas, the highest pressure. Goodness. Sorry, guys. The highest pressure, right, is right here. And that is coming from the aorta. The next highest, right? So this is the pulmonary arteries, which are being pumped. So the blood's pumped into the pulmonary arteries from the right ventricle, but not as much muscle in the right ventricle as there is in the left ventricle. Low pressure is in the vein going back to the heart, but it's not as far away from the heart as the vena cava, which has the lowest pressure. All right, so today we're going to talk about blood pressure and measuring blood pressure and what that's all about, okay? All right, so let's just clear this off and we will talk about blood pressure. Okay, so the first thing we need to know about blood pressure is the instrument that's used to measure it. That instrument is called a sphygmomanometer. So that man word is said as man. So let's highlight that. Sphygmomanometer. Now, if you use blood pressure cuff instead of that big long word, that's just fine. Okay, so it's an instrument that's used to measure blood pressure. So how this works is this instrument goes right on our upper arm. Okay, and you guys have probably all had your blood pressure measured. So what it's doing is it's putting pressure right here on my upper arm. Okay, so right kind of over top of where my bicep is. What is this? There we go. When blood pressure is measured, it's always measured with two numbers. Okay, so there's a high number or a top number and a bottom number. Okay, so we always have a top number, which is what I see here, and a bottom number, which is what I see here. Okay, all right. The top number refers to our systolic pressure. So we talked about that term already, systole. So this is the pressure when our heart is contracting. Okay, so systolic pressure, this is the pressure when our heart is in systole. Now, because our ventricles are so much stronger than our arteries, when we talk about systolic pressure, we're talking about the pressure coming with the blood being pumped by our ventricles, okay? All right, and then the bottom number is the diastolic pressure. So that's the pressure in the artery when the heart is relaxing. So remember, when our heart is relaxing, that's a condition called diastole. And again, when we're referring to this, we're talking about ventricular. Okay, so this is ventricular systole. I'm just going to write vent there. And this is ventricular diastole. Okay, because that's really the big muscle of the heart that's moving the blood out of the heart. All right. So we always have a top number and a bottom number. Now I chose 120 over 80 because that's the typical blood pressure. That's the blood pressure we all want. Okay, that's the gold standard of blood pressure. Not to say a little bit higher and a little bit lower is terrible, but that's kind of the gold standard of what we're looking for. Okay. All right. So let's take a look at this image here. So what we're looking at is we're looking at the heart here being in systole. So systole, we're talking about ventricular systole. So we see the ventricles are contracting, and that's forcing the blood. So systole in our artery, that's when the artery is going to make that bulge, right? So there's going to be more pressure in there because it's pushing out the sides as that blood's going through. Diastole, there's not going to be really much pressure because that's when there is no pump from the heart, okay? So diastole, we see the relaxation that's happening here in the ventricles, right? So this first number, that's the number for systole. That's why we see a cyst there. And this is the number for diastole. Now, here's the sphygmomanometer, and we see the placement of that. Now, this is actually measuring the blood flow through a very specific artery, the brachial artery. And we talked about the brachial artery already. So the brachial artery is the artery that runs right here in your upper arm. So what we're doing is we're putting pressure on the brachial artery, so much pressure that we're stopping blood flow completely. Okay, so we're stopping the blood from flowing through the brachial artery. All right, so let's go on to the next slide here. Okay, so let's look at how we measure. So the first thing we're doing, and you can kind of think about when you go and get your blood pressure checked, right? Your doctor's checking your blood pressure. And my doctor just uses a blood pressure cuff. So she takes the cuff off the wall, she puts it on my arm, and she measures the blood pressure. And she's very, very good at it. I personally am not very good at this. Okay, so let's see what's going on here. So in the first image here, we see on the left, we see that the blood's moving nicely through the brachial artery. Okay, so the first step is to attach this blood pressure cuff and put enough pressure in it that no blood is flowing through. So see how there's no red over here? So the artery is closed. We're blocking the blood flow. Okay. So usually we're measuring at about 150. So that's usually, whoops, sorry guys. So we're usually squeezing this little bulb until our pressure reaches 150. And once the pressure reaches 150, that's usually enough to just cut off that artery. Okay. All right. So then what do? Then we relieve some of that pressure really slowly. And there's a place to measure it. On the ones that we have at the school, it's a little dial. Here we see it in a little kind of a chart on the side. But what we do is we take a little bit of the pressure off, and then a little bit of blood can make its way through. And we're listening with the stethoscope. So this is a stethoscope, and we're listening, and we hear a little noise. And as soon as we hear that little noise, that means a little bit of blood is getting through, and that's the diastolic pressure. Or sorry, that's the systolic pressure, okay, when a little bit of blood gets through. And we're going to keep hearing this noise as we let the pressure come off. So the pressure keeps coming off, keeps coming off, keeps coming off, until the point where the blood flow is normal. And as soon as the blood flow is normal, we don't hear anything anymore. That number is the diastolic pressure. Okay, so when we start hearing noise, that's the blood starting to move through. That's the systolic pressure. When we stop hearing noise, that's the diastolic pressure. All right. So steps to measuring. So the sphygmomanometer is applied to the brachial artery. So that's the one in our upper arm. Inflated until blood flow is cut off. And then we listen through the stethoscope and slowly relieve the pressure. Okay. The first sounds heard indicate systolic pressure. So that's just the blood kind of just spurting out of that artery that's starting to open up. Okay. And then we continue to open up, and we're going to keep hearing that kind of spurting noise until it's opened up where the blood flow is normal. And then that's our diastolic pressure. That's when we stop hearing sound. Okay, so blood is freely flowing through the artery at that point. Okay. So I liked this image because it gives us a sense for what's going on with the artery. So if we look at this image here, we see this is no sound, right? Because the artery is completely closed. Sound is heard because we're starting to open the artery. So the artery is starting, the blood's starting to spurt out. And then our diastolic pressure, the artery is open completely and it's not fighting to get out. The blood's not fighting to get through the artery. Okay. All right. At school, or what we have here, if you look, because how we release that pressure is there's a little valve here that we turn, and you turn that valve and it allows a little bit of air to release, and it starts taking the pressure off of the cuff that's sitting on our brachial artery. Okay. All right. So what I wanted to do here, now I didn't pre-open this, so we're going to just see how this works here. All right. So I am going to share this site with you. And like that. Hopefully this works. Oop, that didn't work. Let's try that again. Share computer sound. All right, just on the chat, can you see what we're doing here? You can give me just a yes if you can see what's going on in the image. We're going to take, oh, just listening. Sound. We stop your sound. That's what we're just slowly letting off the pressure. We're slowly taking pressure, and we're listening for when the sound happens. And then when the sound's done, our systolic pressure is 120. Diastolic pressure with 80. Okay. All right. All right. What I'd like you to do with the chat is give me your two numbers. What's your diastolic or systolic, and what's your diastolic? What did you hear? Okay. Oh, Ethan, you're very precise. Okay. So we have 80 over 50. Okay. So that's about what I heard. So let's give that a shot. Let's see what they say about that. So 80. And we have 50. So let's see if they tell us we're right here. Okay, so they're happy with that. So I gave you the link so you can try this. I'm just going to, I don't know why everything I'm doing is now not working. Hold on 1 second here. All right, so I gave you this link. So you have this link. I'm just going to go back to our PowerPoint and share that screen here. There we go. All right, so this is the practice drill. There's a few things on there that you can do to try to practice hearing. And this second link is just to give you a little bit more practice with measuring blood pressure, okay? If we were in a classroom situation, this would be way better because we could actually take a class and do that, but we're not. I find it way easier to try to do it with this than try to do it with a blood pressure cuff, because you really, really have to get the stethoscope placed in the exact right spot in order to hear the blood spurting through that brachial artery, and that can be a little bit challenging. So I'm always very amazed when my doctor can do this lickety split. Okay, so let's move on to the next one here. So what we need to understand in this class is what's normal and what isn't normal. So when I look at blood pressure, okay, so like I said to you guys before, our normal blood pressure is usually 120 or less and 180 over less. So we're always kind of going to this 120 over 80. So as long as we're sitting at that, we're doing good. Okay. Um, we'll take notes on this in a second, but low blood pressure is usually not as big a deal as high blood pressure. Low blood pressure, we feel that. If we have low blood pressure, we start feeling faint. But if we have high blood pressure, there's no symptoms and then we die, right? So it's referred to as hypo or hyper. Hyper means lots, hyper tension. And we don't get symptoms of it, but it causes a lot of really bad stuff to happen on the inside of our body. So when we're sitting in this level here, that's a warning sign. Now, because we just don't feel any symptoms of high blood pressure, that's why they have those blood pressure cuffs at the pharmacies, because then you can monitor. You can go in every week and actually monitor your blood pressure in order to see where you're at. Okay. Over here, really bad sign. And over here, okay, higher than 180 and higher than 120, it says consult your doctor immediately. You could be at serious risk of a heart attack or a stroke. Okay. So when you're in these stages here, there are things that you can do with dietary changes, exercise changes. There's some drugs you can take to try to reduce your blood pressure. Okay, so this can be really, really dangerous. So it's something we want to take really seriously. Okay, so that's why we measure blood pressure. Oops. All right, so normal blood pressure readings, usually somewhere between 100 over 70 to 120 over 80. Okay, so that's a pretty typical normal range. So if you're getting your blood pressure measurement and you're in that range, you're doing pretty good. Okay, so hypotensive, this hypo word. So we want to remember hypo is a prefix that means less than, right? So hypotensive, blood pressure reading is too low. So if we're at about 90 over 60 or lower, that's not good, but we are going to feel symptoms of that. We're going to know because we're going to feel faint. So people with really low blood pressure might pass out. Well, that's it. That's going to be a sign. Someone's going to watch you pass out, right? Or you might feel kind of dizzy and lightheaded. So that's a symptom that something's wrong. And one of the first things they check is your blood pressure. Okay. And the reason why that's bad, well, if we don't have that pressure, we're not going to have that same amount of blood flow getting to our cells, which means our cells aren't getting oxygen and nutrients. If our cells in our brain are deprived of oxygen, we start to feel faint, right? We start to feel a little bit lightheaded and dizzy, and that's not good. So we would pass out. Okay. So hypotension. Okay. So that's hypotensive blood pressure. All right. Hypertensive. So the blood pressure reading is too high. So anywhere from 140 over 90 is really bad. Okay. Now, high blood pressure is known as a silent killer. So, like I said, there's really no signs or symptoms of high blood pressure. So, this is something that we just have to be careful about. So, people in my age group, because usually people in your age group, we're not really worried too much about your blood pressure. People in my age group, absolutely we are. So, I go for a yearly checkup. And that's one of the things they check is my blood pressure. And then if there's something wrong with it, something has to be done. Lucky for me, that's never happened. Okay. So often there's no symptoms associated with it. So that's why it's referred to as a silent killer. But some of the problems associated with it, we can get an aneurysm, which means that there's a bulge in the side of one of our arteries, which is bad because it starts to weaken. All of times an aneurysm burst, and then blood's flowing out into the whole body rather than a blood vessel. And any cells that need that blood, like your brain or your heart, get it and use it from a stroke or a heart attack. Okay. Other signs associated with blood pressure, so things happen as a result of pressure. So it have heart attack, okay, high blood pressure, means that we can end up with a buildup, which can stop blood flow from going into our heart or to our brain. We can end up with our heart not working properly. We can end up with our kidneys not working properly. We can end up with our blood vessels because we have so much pressure that's going to build up in our eyes that can push back onto those receptors that detect light, and we can become blind. So high blood pressure is not good. This is something that needs to be dealt with. Okay. And then we'll just talk real quickly about pulse. All right. So normal or healthy pulse. Healthy pulse is usually between 70 to 100 beats per minute. We usually talk about pulse as being about, 60 to 100. Usually an average is about 70 beats per minute. Okay. Healthy pulse depends on age. Okay. So the older you are, where we're expecting that range of pulse to be varies. So when we talk about hitting that zone where we get the most burning of calories, that zone is higher for someone who's young than someone who's old. So it'd be higher for you than it is for me. Okay. Depends on your weight. Okay. How much, so often that means depending on our cells, right? How many cells we have that are requiring nutrients from our blood, our level of fitness. So we talked about if our heart isn't as strong, then our stroke volume is smaller, which means our heart is going to pump more in order to get the same cardiac output as a similar sized person who's more fit. Gender, females tend to have a slower pulse, slower, I think. What we want to remember is cardiac output here. Just lost my pen. Oh. Why did I just lose you guys? Just give me a second, guys. I think my computer inadvertently shut off. Oh, maybe not. Okay, sorry about that, guys. I'm not sure what was going on there. Let's get back to this. And there we go. So we want to remember cardiac output is depends on stroke volume and heart rate. Okay. Heart muscle is stronger with regular exercise. Heart rate is 40. Yes, it's 7. So it's to go up a little bit as you get older. Excellent. And you can measure your pulse. Just measure it for a minute and you are. And then obviously, next slide. It's not effectively being are getting the oxygen that they need. Okay, so this isn't a good heart is beating too slow. We're not that movement of blood that we need to love dub. About this earth are love dub. So when you're listening to the heart, it's hearing one sound. You're kind of hearing together. Love dub, love dub. It means ventricles together. So love dub, love dub, love, love, and that's sound here. So love, atrial valves, so ventricles contract. And then the semilunar valves close when the ventricles relax. Okay, so that's our valves closing. That's the sound that we're hearing. Okay, so our first sound, lub, so closure of the atrioventricular valves, and then dub, closure of the semilunar valves. Okay, so make sure when those sounds happen and you understand that. All right. Heart murmur. It's not uncommon for babies to be born with a heart murmur or for people to have a heart murmur. So heart murmur just means instead of that lub dub, lub dub, lub dub, you also hear this gurgly kind of sound coming through the stethoscope. Okay. And what this means is the blood isn't moving in the right directions in our heart. Okay. 1 second, guys. What? Yeah. So This could be a couple of reasons. It could be that our heart valves are leaky. So heart valves are supposed to force the blood to go in one way, but sometimes the blood goes backwards in the valves. And you can hear that because it's not a direct lub dub of the valves slamming shut, because they're not all shutting, right? Because the blood is leaking through them. It can also mean that there's a hole in the septum. So remember, the septum is that muscle that separates the left and the right side of the heart. So the left and the right side, okay, so there's this big muscle in the middle. Sometimes there's a hole. And that means the blood's moving in a weird way from left to right or right to left. Okay. And then you're going to hear that sound with the stethoscope, and that'll be this little gurgly sound. Now, a hole in the heart, that's what this is referred to as. This hole in the septum isn't good because the deoxygenated and oxygenated blood are mixing. So that makes the pumping of the heart much less efficient. So what can happen if you have a hole in your heart? I went to school with a boy who had this years and years ago, and his lips were consistently blue, but that's because he wasn't getting that oxygenated blood throughout his body as much as he needed to. Okay. All right. Any questions, guys? Okay. So remember what I said before. I'm postponing the quiz until tomorrow at noon. I'm not going to post any questions for this until Wednesday. So don't look for any handouts or anything for circulation until Wednesday. What I want you guys to do is I want you to spend some time just going through your notes for blood vessels, going through your notes for blood. If there are things you have not handed in this unit, feel free to hand them in, okay? I would rather get your work than not get your work. So hand your stuff in, all right? If you've missed any quizzes, send me a quick text or quick email, and I will open up the quizzes for the people who missed the heart quiz, okay? So let me get that work right away, because we are going to be, once we're done this module, we're done this module. So I want you guys to be able to get your work in. Yeah, so Jason, I'll answer your question in just a minute, okay? Any other questions about this? All right, that is it for today. And just hang on, Jason, and I'll answer your question. And we will see the rest of you on Wednesday.